This morning, we're going to cover our 6-step program for a healthy building, prescription for a healthy building, and that's going to be some presentations in different sections by myself and Jim Zarsky from Nexent, one of our technical assistance providers and assessment providers we use here in the city of Fort Collins. Okay, then we're going to hear 2 case studies of different size, one large business, one small nonprofit, that are going to go into detail on how they have applied these steps in recent years to help improve the health and wellness of their own building from an efficiency perspective. So without further ado, we have a very special guest this morning. Alice is CEO of the Fort Collins Widgets R Us business, and she really has some, wants to talk a little bit about the issues that she's facing with her building.
Good morning, everyone. Good to see you. Listen, I have to be honest with you. We're in rough shape. Our building is expensive to run and to maintain. We're getting behind on paying our bills. Because our bills are so high, it cuts into our profits. We need some new ideas on how to cut costs and save money. What do you think? Anyone with a good idea?
Let's buy a better building.
Buy a better building. Well, we can look into that. Any other ideas? Work by candlelight. Wouldn't that be romantic? Don't know how much we'll get done. Anything else? Sell the building, all work from home. That's an interesting idea as well. Anything else? Keep all the lights on, all the electricity, and the AC to increase productivity. That might work. Anything else? Yes?
I've heard of this Dr. Efficiency. He's supposed to be good at this kind of stuff. Have you ever heard of him?
No, I haven't. But perhaps he could help us. It couldn't hurt. We could try. Any kind of idea that we have, it couldn't hurt to have Dr. Efficiency come here and give us some kind of information.
Good morning.
Good morning, Dr. Efficiency. Glad you could come. Thank you for coming.
I'm Dr. Efficiency, and this is my diagnostic team. What seems to be the problem?
Well, we're in rough shape. The building is expensive to maintain and to run. We're getting behind on paying our bills, and our bills are so expensive that it's cutting into our profits. We need some ideas on how to cut costs and save money.
Well, I recommend my 6 steps to a healthy building. Let's start with step number 1. Check your symptoms and vital signs. What unhealthy symptoms does your building have?
We seem to fill the garbage bins up with stuff that I think could be recycled, like cardboard, cans, and some others.
So recycling it, part of the building problem. Anything else? Cold, drafty offices, all right? That is a problem. Anything else? A weird smell fills the second floor. Rumbling in the building when the machinery starts. I see. Anything else?
It's like the sprinklers are always spraying the buildings and sidewalks and sometimes customers.
This is a major problem when the sprinkler systems are not efficient, when they're coming off. That's not good. Anything else? Well, I think we're off to a very good start. We are going through the other steps. I'm going to turn it over to my able assistant, John. I have another appointment, and I think we're well on the way to helping you with your problem. We're diagnosing, and
I'm anxious to hear what he has to say. Very good. Thank you very much, Dr. Efficiency.
John.
How many of you would consider yourselves the owner or a patient's rep? So you're like an owner of a business. You own a building, in this case, out there. How many of you would consider yourselves a tenant, or you spend time in buildings? Now that one, everybody should raise your hand. We all spend an enormous amount of time in buildings. We aren't focusing today so much on the why of why you should be interested in this, but there is great value on both people in the buildings as well as from an ownership perspective. So from a tenant perspective, you can, if you have tenants in your building, higher rents, a better space, it's more marketable. From an owner, you get more productivity out of your employees, lower costs, simply with energy and water savings, and a healthier business and healthier set of employees. So where do we start with our symptoms and vital signs in our step one? Really, you need to start where you are, and we all kind of come in at different places in this. But we want to make sure first to look at some of the basic information that's available for your building, looking at your bills for electricity, for water, for solid waste, as well as rates in those. We're going to talk a little bit about benchmarking. How do you measure? How do you decide whether you're doing well or not doing well? You're going to ask a lot of questions. And these are things that you can do kind of upfront is what I'm talking about, before you would actually engage somebody to do some more detailed analysis, assessment, or diagnostic work. So step one is bills and rates. Another quick question. How many people know where their electric meter is on their business? Okay, how many people have ever looked at it? Or water meter? The same goes with bills. A lot of us, I know I can easily even get in the habit, and I'm an energy nerd. The bill comes through, you write a check or you debit it from your account, whatever you do, off it goes. There's actually quite a bit of information on a lot of bills that can help you understand how you're doing. So just some very basic tracking in a spreadsheet type of format can help you see how you're doing again over time and against yourself. It's not a complex process. Some different ways of charting the information. Certainly as we talk about our assessment process in step two, some of this comes with it. You get to help work with us on an assessment, you're going to get some tracking and information and tools similar to this. Rates are another important aspect. Rates are kind of tedious. They're pretty boring to look at. Exactly how you get charged for electricity, how you get charged for water, but I'm asking you to do it anyway because it can be a very important and useful tool to help you immediately reduce some costs if you find out where the opportunity is. I'll be the first to admit that for Collins Utilities, we do not have the simplest of rate structures on the commercial side. Depending on which category you're in, there's a number of different groupings and charges and calculations that have to be done to do that. But by understanding that, then you know where the opportunity is. So the bills and rates piece really is the first step to start to track and pay attention to it, because it's really how we what we pay attention to, then we can start to manage and make adjustments with. So think about benchmarking. What does the word benchmark means? It's really to find a surveyor's point so you know where you are. So if you're up in the mountains or they're all over the country, you'll find things like these benchmarks that were put out by the U.S. Geological Survey, so we can know where we are. Similarly with a building, a benchmark is a yardstick, so you can start to compare how do I compare to others? How do I compare to myself over time are two of the key elements of a benchmarking exercise. So some of the reasons you might want to do this, sort of why do the benchmarking, is setting a performance target for your building. Just as you might have a quarterly goal for profits or for sales, or for the number of units out the door, things like that. Establishing a target for the energy, the water performance of your building, or the cost performance, is going to help you make that, as opposed to out of sight, out of mind. You can really identify inefficient buildings. If you go through this process and you find out on a scale of 0 to 100, your building is a 4, well, you got a lot of opportunity, because that means 96% of the other buildings of your type are more efficient than yours. You can also identify high performers. You can get recognition for being a high performer. So the same process works on both ends of the scale. At a rough scale, it can help you identify what the cost savings potential is. You know, it's not too hard to hit the midline of somewhere, so if you're down low, you can come up with some quick numbers on what you might save. And you can kind of track yourself over time. So we have mileage stickers on cars. We don't have anything like that on buildings yet. There's a number of different metrics to actually do that. I wasn't going to go into great detail on this. The most common one, certainly in the US, is just the energy use intensity. So it's energy use per square foot for a particular type of building. So if it's a school, or if it's an office building, if it's a retail store, we can measure that, and it's in kBTU per square foot per year. Energy cost intensity, dollars per square foot per year, is also another really common one. It's a little harder to compare because the rates are different. You know, a building in Denver or San Francisco or Fort Collins is going to score very differently because of the energy costs. But still, that's very, very important for property management companies, things of that nature. They're going to look at that cost per square foot. And the other is a numerical ranking or rating, you know, where you're on the 0 to 100 scale. And what I've found is engineers, building operators, kBTU per square foot per year. They can think in those terms really easily. Your property managers are going to like this. And your senior level management and decision makers, keep it simple. We score an 80, we score a 20, whatever it is, and that's a really useful metric there. So I want to throw out some examples of different types of targets you might use. We see these a lot in new construction projects, but it can apply to existing buildings as well, and what they actually mean, how useful they are for getting something done. So you could say, well, I want our building to use 20% less than an average building. That sounds like a nice goal, but could you really define what an average building is? You know, a percentage or, you know, varies. It's quite squishy. You could say you want to be LEED rated. That's another really good goal, but there's lots of different ways to get to a LEED rating. You could do the same with an ENERGY STAR label. It's very useful. It's a good process. But what if yours was use no more site energy than 33 kBTU per square foot per year? It's very easy to track. It's very easy to tell how far you are from reaching your goal or not. So you use some of these tools to come up with that number, but you want a number to go after, and then it's trackable, traceable. One of the simplest tools to do the benchmarking is ENERGY STAR Portfolio Manager. It's based on a very large national database of buildings called CBEX, and you can create your own account online. It stores the data for you. You can put in your electricity, natural gas bills, et cetera. A few other real simple information about square footage, number of employees, operating hours. It kind of normalizes for a number of things. And you get a label out of it. And that gives you that score as well as the numerical numbers. It's a free service, so it's a great tool. If you manage multiple buildings, then you can manage a whole portfolio of buildings within this tool and keep track of that over time. And if you do score high enough on the scale to receive the ENERGY STAR label, you can apply for that labeling and get a nice plaque for your building as well. On the water side, it's certainly a little more challenging than on energy. There's not as robust set of data out there comparing water use for different types of buildings, but there are some. So certainly in restaurant sector, there's some pretty good numbers out there. Some of the other ones have really consistent populations like schools, and to a lesser extent some other buildings. So that's kind of the bad news or the challenges. The good news is one of the easiest things to do is to track your own use in your own history. So if you're going from one year to the next and there's huge differences, then that's a trigger to go look at something. It's also relatively easy to separate out indoor and outdoor water use just on a seasonal basis. So just looking at those bills on a spreadsheet format, it's real easy to sort of say, okay, here's my indoor use, and here's what the outdoor piece is. And that's certainly something that we can help with as well. As I mentioned at the beginning, the rankings are really valuable for non-technical decision makers. They like those. They're simple and easy to remember. The numerical ones are more valuable for technical, and the tools are very easy to use. So instead of 50 miles per gallon on your car. We'd like to eventually see people start to know and understand what their number is for their buildings. Our local school district is one of the best examples of a group that has done that. So when they look at all of their buildings, they're tracking this number right here, and when they build a new building, they're telling the architects and engineers, the design team, what number that they want out of that building up front. We're also talking a little bit about trash, solid waste for recycling as well today, and that it is another sign of your building's health. It is also a cost that you bear for disposing of that. So how do you assess your trash? And the goal is really to reduce the amount that ends up hauled away to the landfill, and by thinking carefully about that, you should also be able to reduce your costs. So one of the things is to look on your bill, what information is there? A lot of times on a trash bill, there is no information on the bill. So really working with your hauler on things like the container size, the pickup frequency. Some of the things that you can find out on your own is, are those containers full when they're being hauled off? Are you wasting essentially money and space by having a 3-yard dumpster hauled off when it could be smaller because you don't need as much? Those are the types of things you can look at as well. After looking at understanding your current level of service you get from your providers, you might want to take a look at what's in your trash and trying to assess how much of that is actually recyclable material. In general, removing things from the waste stream up front is a good cost measure, it's a good efficiency measure, and obviously has benefits in the environmental realm. So you can do this somewhat on the quantitative or qualitative kind of visual check way of doing that. So kind of find out what's going on with your service, and then look at actually what's going out in your trash heap. Similarly on recycling, you would want to look at the types of materials that you hopefully are already recycling. And the haulers, there's a lot of I've learned a lot about this from our partners in the ClimateWise program. A lot of it is negotiating with your providers to maximize the level of service you have between waste and recycling, and looking at the material types, and similar to trash, your level of service, container size, pickup frequency, and how much volume is in there at the pickup. So then lastly, the last couple of slides on step one is, what are we really after in buildings, in our business space, and even in our personal space, whether we're working or at home? And it's indoor environmental quality is the term that's used in the industry, and oftentimes that gets limited to just air quality. But it's really more than air quality. So yes, we need to make sure that we have good quality fresh air, enough fresh air in our buildings for the number of people that are in there. But it also comes the thermal comfort, the lighting layer, the luminous quality, the acoustic qualities, and the aesthetic qualities. You put all these things together, air, thermal, luminous, acoustic, aesthetic, and you can end up with not only a healthy and safe environment from a legal perspective, but also a productive environment that's really, how many of you right now love your office space? It's just a wonderful place to be. Okay, I see a few hands. How many might say the opposite of that their space is not very good for one of these reasons: thermally, lighting, acoustics, aesthetics, or air quality, It's not a stretch to think that if we really like our space, we're comfortable there, we're relaxed, and we can be very productive employees, productive people. So one of the things in this up front is to not be scared to ask your employees about their space. Jim's going to talk a lot more about, as you go into detail on learning about diving into the specifics of a particular building, but people understand pretty well, and some of the comments you heard this morning of, it smells funny, or my office is drafty, or it sounds like there's a train coming when the air handler turns on. those are real symptoms that can be addressed through an assessment process. And typically you fix those, you can end up saving energy and improving the environment at the same time. So it's a win-win situation. But ultimately you want your building to support your mission. Your mission is to do whatever your business is doing, whether that's providing a service, selling shoes, manufacturing a product, whatever it may be. Similarly, your service providers, you're probably going to have somebody that comes in and does maintenance on your mechanical systems. You may have a custodial service. Maybe somebody does lighting. Looking at the services they're providing, asking them the questions, what are you doing to help my energy efficiency? What are you doing to make sure that my employees are safe and comfortable in their environment? And they may stare at you with a blank stare and go, huh? I changed the filters. That's my job. But the better ones will say, well, here's what we can do, and engage them as well, because they're part of sort of the life of a particular building. So my summary for step 1 in our 6-step program is collect your bills, electricity, natural gas, water, solid waste, etc., for at least 12 months. If it's easy to go back further and get a little bit more, you can get a little more history. It's more valuable. You can enter that information into a tracking spreadsheet and keep doing that over time, because that awareness is what's important. Or talk to us and we have some tools that we can help you with that. Create some kind of chart or use one of ours and post it, print it out and post it somewhere where you can see it, or possibly where your employees can see it as well. Start to engage them in, part of our business is managing our costs. Make a plan for learning from your employees and service providers. And the next one is going to be to schedule an efficiency assessment to move on to step 2 in our 6-step process. So with that, I'm going to turn it over to Jim, who's going to walk you through steps 2 through 5, I believe.
Great. Well, welcome. Good morning. So I'm going to cover the next 4 steps about making sure your building's efficient, healthy, works well, how we diagnose it, opportunities for help out there with Fort Collins Utilities, etc. What's in an efficiency assessment? Well, there's 2 paths to go here. Of course, the path of least resistance is probably getting involved with Fort Collins Utilities and having one of their energy assessments done on your building or climate-wise assessments. But what I'm going to focus on, and we're going to, again, continue to tie this back to how Fort Collins Utilities can help you out, is I want you to become the expert yourself. And as best as I can do that in the next 20 minutes and telling you about how buildings work. Because it's a lot like anything in life. If you take your car into the mechanic or if you go to the doctor, if you've done some upfront research and education yourself and you kind of become a semi-expert, it tends to make that visit or that interaction more productive. And that's the way I feel with buildings. There's so much about buildings and how they work, and if you know some of the technologies and the controls and how they're supposed to work, then those are the kind of questions you can ask your maintenance contractor or whoever works on your building to find out if you're maximizing energy efficiency in your building. So I'm going to go over these general steps, and these are the steps and the systems that we tend to review when we do an energy audit. The first starts off with general diagnosis, interviewing the staff that's responsible for running the building, the staff that works in the building. I'm going to cover the lighting, HVAC, envelope, and controls. And then, that's all the stuff that gets installed, when the building is built or when it's renovated or retrofitted. But then there's the ongoing, periodic assessments, PPMs, periodic preventive maintenance, ongoing commissioning. I'm going to talk about all these terms and discuss them in greater detail here. So whether this is you or this is me, the very first thing we do when we walk into a building is we do a building interview. Ideally, we like to do this with someone who actually is in charge of running the building systems, programming them, fixing them, maintaining them, because that's really where the energy use is, right? It's running the boilers, the chillers, the air handlers, the lights. Granted, it's nice to talk to a few occupants and find out, is this a healthy building? Is it a sick building? Is it comfortable, uncomfortable? But really, we like to kind of go right in for where the energy is being used, and that's in the building systems. And so we'll spend anywhere from an hour to a few hours talking to the maintenance staff because, honestly, we're only there for a few hours or a half a day. This guy works in this building 40 hours a week, year round, and there's no way I'm going to be able to figure out how this building operates in 2 hours when this guy or this woman is in there year round. And so we spent a lot of time asking about past, present, future renovations, current schedules of operation, current comfort, maintenance issues. Does the building meet heating and cooling loads on design days? That's always one of my big questions because oftentimes engineers tend to oversize things, right? If things weren't oversized, if there wasn't a factor of safety built in, things will fail, right? The bridge didn't have that factor of safety built in. If you have a major snow load and a bunch of trucks on it, it might break. But HVAC is no different. Lighting is no different. Granted, you can oversize things so much to where you increase your energy use as well. And so honestly, if the building's not meeting load on design days, and that tells me that maybe there's a controls issue, there's a ducting issue, there's maybe some other things going on, and once in a while, it can get back to the size of the equipment, or the use of the building has changed over time. We've gone from being an office space to a data center. I mean, that's a pretty extreme example, but the cooling is just not there to keep the space cool. We also spent a lot of time asking about building controls. Is again, basically your DDC system in your house, your direct digital control system is your programmable thermostat. Programmable thermostats, of course, can't control a large 30-story, 500,000 square foot building. You need to get a little more sophisticated, so you have to use a computer with some software attached to it. And that's how you control the building. That's what I mean by a DDC system. But older buildings use pneumatics. If you have a typical office building under 50,000 square feet with anywhere from 5 to 10 rooftop units, they're usually controlled with programmable thermostats. So there's a variety of control systems out there. So we try to get our arms around what type of control system you have, what type of control features it has. And the biggest one is always scheduling. Economizers is the second biggest feature that we like to look for. Making use of cool outside air conditions to cool the building. And then there's a variety of other features that if you have an advanced control system that usually have these capabilities built in. But the goal, as I mentioned earlier, is before we leave the site, we like to understand how this building operates day to day and seasonally. And you may ask, well, what does the schedule have to do with making my building work more efficient? Well, usually I have to go back to my office and put together energy calculations and predict savings of, if you turn this piece of equipment off, or if you open this outside air damper a little bit more when it's spring and fall, and determine how much energy you can save as a result of that. Well, I have to do calculations. So a lot of this information I'm collecting is to kind of gather my baseline condition. What's your baseline energy use? And then the energy savings is the new condition, the difference between the new condition and the baseline condition. And so, usually by the time I get through this interview, I usually kind of have an idea about what 75% of the energy conservation measures are, believe it or not. I don't have to walk through the building. I can just talk to the individual and kind of farm from there what I think is wrong with the building. And before I leave the site, I usually like to go over my ideas and what we call energy conservation measures. And even talk about funding and budget cycles, because a lot of times they'll be up front with us. They'll be like, well, our fiscal year ends, September 30th, and we'll get more money in October, and here it is April. So we'll take these ideas, we'll present it to the board, and we'll come back maybe in the fall and consider implementing them. Those are always good pieces of information to know. So this kind of gets into more of the specifics of the types of systems you have. Of course, there's lighting, there's HVAC, the control systems, the building envelope, and the plug loads. Lighting. Most buildings have fluorescent lighting in them, and there's a reason for that. Fluorescent lighting, it's the most efficient. I shouldn't say it's the most efficient. It's kind of middle of the road, believe it or not, in terms of efficiency, maybe kind of towards the upper half of the spectrum. But fluorescent lighting also renders colors really well. Okay, there's other types of lighting out there. There's incandescent metal halide. The orange street lamps you see are high pressure sodiums. The green ones that you see in industrial parks are mercury vapor. what we call high intensity discharge lamps, they use a lot of energy, but a lot of times they don't render very well. And of course, when you're sitting in an office and you're trying to read something, you want something that renders. If you tried to go in the parking lot and read under one of those orange lights, those orange high pressure sodiums, your eyes would actually start to hurt after a while. And but fluorescent, you tend not to have that problem. And so what ties into fluorescent and its quality, of course, is the light qualities we just talked about. There's also something called color temperature. The color temperature is, I think we've all been in a situation where, you went to Home Depot or Lowe's or whatever, and you bought a new fluorescent tube for your kitchen light or your bathroom or whatever, and it's a different color than the one that was in there before. Well, there's a term, it's called CCT, correlated color temperature. The lower the Kelvin on that, the warmer it is, and the oranger the light's going to be, and the higher it is, the bluer the light is. And so fluorescent tends to have a pretty good overall color temperature for rendering and seeing objects as they truly are. Now, CCT is on the scale, or I'm sorry, not CCT, the CRI, the color rendition index, is on the scale of 0 to 100. 0 is the worst, and then 100 would be daylight. So if you're trying to figure out what to compare your rendering to, you want to compare it to daylight. And that's why daylit buildings are so great, because you're getting all this natural light in, everything looks great, it appears as it should. But when you start throwing in different types of lights, it kind of shifts the colors of what you're trying to look at. So you probably have heard of terms like T12, T8, T5. Well, the T stands for tubular. So that's your typical linear lamp and like a 2x4 fixture. We don't have any in here, unfortunately. These look like these are incandescents. But yeah, in your typical 2x4 lamp fixture that you see in a building, you'll often have T8s or T12s in it, maybe T5s. The 12 and the 8, basically the diameter of the lamp is measured in 1/8 of an inch. So when you have a T12 lamp, the diameter is 12/8 of an inch or 1.5 inches. And 8/8 would be an inch. T5 would be 5/8 of an inch. That's all that means. T8s are more efficient than T12s, mainly because you're using a electronic ballast, which uses a lot less energy than a magnetic ballast, which you need for a T12. So you're looking at about 30% energy savings going from a T12 to a T8. T5s are fairly efficient, but I wouldn't say they're leaps and bounds over the T8. But they're very bright. You get a lot of light out of a T5, and so they're more applied in high bay situations, or if I see them in an office, usually they're applied like in an indirect lighting situation where you're bouncing the light off the ceiling and then reflecting it down. And then the last but not least is there's controls. There's ways to control these lights. The most basic is the switch, the on-off. There's occupancy sensors, which I have a picture of one there on the lower left. There's daylighting controls, which, believe it or not, these daylighting sensors actually have the daylighting control feature built into them. Basically, the way that works is if there's enough light already in the room, it won't turn the lights on, and there's an adjustment screw on them. And the last one is what we call sweeps. So that gets back to that DDC, that building control system. A lot of times, building control systems will have a schedule built into them where it'll shut off all the lights after occupied hours, that sort of thing. HVAC is the next type of building system, and this is where usually most of your energy use is involved. There's various types of HVAC systems out there. There's rooftop units. Those are probably the most common, most of what probably here in this room we're used to dealing with. There's central systems. What I mean by a central system is you might have a central chiller or a boiler that's producing hot water or steam or chilled water. You pipe that around the building to a couple of air handling units or fan coil units, and that helps conditions the space that way. There's of course a residential type systems. That's what we usually call a split system. And the reason why it's split is because you got the condenser sitting outside and the evaporator is inside. It's split. And then all you're running is a refrigerant line between two refrigerant lines between both units. And that's typically what your AC is in your house, is a split system, and then you have a gas-fired furnace inside. And then I'm also going to get into types of air supply and ventilation. Other things that go into designing a system, of course, is temperature, thermal comfort, controls, schedule, so forth. Most buildings are controlled at 72 degrees, but when you get into gymnasiums or hospitals or lab spaces, HVAC design becomes a heck of a lot more complicated because you got outside air requirements, you got thermal requirements, etc. So, there's a picture of a rooftop unit there on the left. Oftentimes we call them packaged rooftop units. The reason why they're called packaged is because everything's in a box. All you have to do is you have some ductwork down the building below the roof curb. You run some electrical there, a gas line. You drop this box with a crane on the roof. You hook everything up and you're done. Hook up the thermostat. Real quick, easy to install. And typically you see rooftop units in buildings under 50,000 square feet. Now, when you start getting into a high-rise situation or a building that's 10, 20, 30, 50 stories, whatever it is, you can't have a bunch of rooftop units sitting on the roof running all this ductwork down to the bottom of the building. And so that's when you start getting into more of a central system where at that point it's easier to pipe chilled water and hot water around the building, and then you have these air handlers on each floor or that serve several floors that condition the air based off of that chilled water and hot water supply. Other types of HVAC systems, maybe you can consider them more efficient or more green. Ground source heat pumps are making a pretty big stake in the industry in the last 10 years. Basically, the ground source heat pump, you're using your ground as your condenser. Whereas on your split system, you have a condenser sitting outside and you're blowing the heat to the outdoors. That's called an air-cooled condenser. Well, in the ground source heat pump system, you're actually, instead of rejecting that heat to the outside, you're using the cool, constant temperature of the ground to reject that heat to the ground. And essentially what you end up doing is storing that heat down in the ground. And then when you switch over to cooling season, during the summer you store that heat in the ground, and when you switch to heating season, you pull that heat back out and use it to heat the building. And the efficiencies tend to be about 20% higher or so compared to a DX system. And then evaporative cooling, swamp coolers, we call them evaporative coolers. A swamp cooler we refer to as a direct evaporative cooler. It's direct because you're putting the moisture directly into the airstream and you're using that moisture to cool the air. Indirect is where you actually indirectly use water to cool the air, and you blow the air over a heat exchanger instead. And evaporative cooling works great in dry climates. That's why I see swamp coolers all over the place. And there's no reason why we can't be using more evaporative cooling to cool our buildings as well. They work really well. Thermal storage. That's something that, I don't know how common it is here in Fort Collins, but I know we have looked into it on a few projects in the past because of the high peak demand charges in the afternoon. So sometimes we'll get through that peak in terms of, by using what we call thermal storage. So thermal storage would be something like that tank you see in the middle there, where you store chilled water or ice or even hot water. And it allows you to basically turn off the main energy using systems and kind of float through the peak period by pulling off that tank. And I wouldn't say thermal storage is really a green technology. It's more of a cost-saving technology. You're using it to avoid paying high demand charges. Because usually, especially if you're going to produce ice with a chiller, you actually have to make the chiller run harder. And by making the chiller run harder, it uses more energy use. But you're doing that during off-peak times, like in the middle of the night, when energy costs are low. But you can save a lot of money off by not hitting that peak in the middle of the day by pulling off the ice tank during the day. There's radiant heating and cooling. I just have some pictures there of some tubes running through the floor, and then there's also heat recovery. What heat recovery is basically if you have an exhaust fan on the roof that's exhausting a lot of heat out of the building year-round, instead of just blowing that 75-degree air out into the atmosphere, you can actually you can install what we call a heat recovery wheel or an energy recovery ventilator, pull that heat and use it to preheat the outside air coming into the building. And the heat wheels are fairly efficient. I mean, you can actually recapture about 80% of that energy off that heat going out of the exhaust stream. And can save some heating energy that way and some cooling energy during the summer. So, there's also a couple different types of ways of delivering air to a building. You may have heard of VAV, VAV stands for variable air volume. That's a system that basically where you vary the airflow. Instead of just having a constant volume system where the air speed, the fan speed is constant, you actually, with a VAV system, you vary the fan speed based off the load in the building. VAV systems tend to be more efficient because of that, because you actually track the speed of the fans with the load of the building, whereas a constant volume system, you have no way of really cutting it back if the load in the building is low. So you're just using the same energy all the time. Then there's also some other, then the other thing we like to look at is ventilation. Ventilation meaning just the amount of outside air you bring into the building. There's a minimum outside air. Now all commercial buildings for the most part have some sort of minimum outside air they bring into it. Granted, I have done audits on buildings where there's no outside air, so basically they rely on what we call infiltration. Infiltration would be air that comes in through leaks and cracks around doors and windows, opening and closing doors when people come and go, or they can have operable windows. Open the window and let the air in. But commercial buildings, usually you have some sort of minimum outside air you bring in, not only for keeping the building pressurized, but also for air quality. You want to have, you have lots of people in here, people build up CO2, and the CO2 builds up, people start getting tired, they don't want to be there anymore. Well, the economizer and the minimum outside air help combat that. Now, an economizer is basically the same thing as an outside air damper, but it actually will open up if it's like 60, 70 degrees outside to use the outside air to help cool the building, what we call free cooling. And then another type of ventilation is what we call demand-controlled ventilation. So this room would be a perfect example to use demand-controlled ventilation. When no one's here, the lights are off, we don't need to be pumping a bunch of fresh air into this room, right? So we're just heating and cooling air unnecessarily because there's no CO2 load. But with a lot of people in this room, if they had a CO2 sensor in here, they may or may not, I don't know the particulars of this particular space. If the CO2 starts going up, then they'll start opening up the outside air damper and bringing in more fresh air. And we call that demand-controlled ventilation. So then, so now you have your various types of HVAC systems. Now, how do you control them? And we talked about this a little bit earlier. And there's programmable thermostats, which she just adjusted. I guess maybe I had an impact on that. There's manual thermostats, there's pneumatics. I got a picture of a pneumatics board up there on the right. The picture on the left, that's what a direct digital control system looks like. So basically pneumatic is air. If you have a pneumatic impact wrench, it's run off of compressed air. Building controls can run off of compressed air too. Of course, not as high of a PSI. Instead of 100 PSI, we're running off of 15 PSI. But yeah, the way buildings used to be built and controlled, they used to have boards like that to control the dampers and the valves and so forth. And they actually, believe it or not, work fairly well when they're tuned. Of course, you reach a point where there's just so much you can do from a control standpoint, and that's when going into a software package on the DDC system, you can control the building a lot more efficiently. But I have personally tuned up pneumatics and gotten them to work more efficiently, and they tend to work pretty good. And then last but not least, there's time clocks. And so a lot of times with these pneumatic systems, you can have time clocks. And really all a time clock is exactly like that timer that you plug into your wall to have your light turn on and off at certain times during the day and night. That's basically what a time clock for a building is. You have all these little settings on a big wheel, and you determine when things are going to turn on and off. And that would be more of a manual time clock, but then you also have digital time clocks as well. So, control settings. Do you know what your settings are set at? Does anybody know that in this room? What their heating and cooling settings are at? Are they just on hold? So a lot of times we'll go in and see these programmable thermostats, and it's just on hold. And of course, that's great. You got a programmable thermostat, but now you're overriding it, so we're really not making use of it. Who decides on the settings? That's always another issue we get into. Is it the people in the space? Is it the maintenance staff? Is it the owner? These are all kind of good kinds of questions I'd ask and ponder and maybe come up with a good solution there for everyone you work with. The schedule, ironically, when I go in and do building tune-ups, the number one energy saver is schedule, believe it or not. You think as ironic as that is, oftentimes the reason why that is someone came in, whether it's a judge or a CEO or just a worker or whatever you want to call it, came in one morning and they were really uncomfortable. It was really cold or the building was really hot, and so all of a sudden, that maintenance guy does not ever want to hear that complaint again, especially if they're a high up person like a judge or a politician or someone like that. And so a lot of times they'll just override the building. Instead of getting this complaint, I'll just run the building 24/7. And of course, there's a lot of modern controls out there to prevent having a building be cold when you walk in. And oftentimes, if a building is really cold, it just means the controls weren't set up correctly. Or maybe instead of turning, if someone walks in at 7 and we actually turn things on at 6:30, well, maybe the next morning we should turn things on at 5:30. Well, it's better than running it all night, basically what I'm trying to say. And then, that kind of covers lighting, HVAC, controls. The next big building component is the envelope. Now, the envelope, there's oftentimes not a lot of things you can do with the envelope once the building has been built. I mean, you can do it, but it's really costly. You can add insulation to the walls if there's no insulation, or if it's a masonry wall and the building was built in the 1920s, you can fur it out and put insulation in the walls. And do that sort of thing, but it's really expensive to do that, and oftentimes the paybacks are not very good, or they're not within what we would expect would be a good ROI. So I tend to hit more of the things that you can do with existing buildings. The first one starts off with sources of infiltration. This picture we actually took just here on the recent audit. Look at your doors going into your building. Do you see daylight around all the gaps? And I realize that the lighting, you may not be able to see it very well, but that's the first thing you can start with is weatherization. Whether it's installing foam or rubber seals or caulking around windows or those cracks. That's the cheapest and easiest thing you can do to an envelope. Keeping the building positively pressurized. The reason why that is so important is because I'm sure we've all been in buildings where you're standing inside the lobby and the wind is blowing right in the door, or you hear this, you hear that high-pitched squeal of the air being pulled into the cracks. Well, usually if the building is sucking air in, that usually means it's negatively pressurized, and on a really cold or really hot day, that can actually make things uncomfortable in the building. So ideally, you want to keep the building slightly pressurized to kind of keep the cold and the outside conditions out. You can do retrofits on windows. Of course, everything from flat out replacing the window to installing films on windows. You can install like a low E coating. I caution you on installing different types of window tint, because especially if the tint is very dark, basically that'd be like painting your window black or painting your car window black. All that heat's going to get absorbed and it's going to make your window hot. And then that's going to make your building hot. But obviously there's more improved technologies for window tinting out of them, and there's like clear coats and things like that can help reflect a lot of the infrared and so forth out. Last but not least, there's trees. Trees are a good thing, but they take a while to grow. Cool roof, that's a good retrofit that I've seen. And basically a cool roof is a white roof, that picture there on the bottom. And the net energy, there's kind of a flip side of the coin here, because if you go and paint your roof white, and let's say your roof was brown or black or whatever, then you're not absorbing that heat during the winter to help heat your building. But then, if it's white in the winter, then you're reflecting all that heat. But then in the summertime, when it's hot out, you're reflecting all that heat and you're making your cooling system run less. I have run lots of energy models on cool roofs, and the baseline versus the proposed condition, I don't find it to be leaps and bounds going from a white roof to a darker roof, but usually it's a net positive to have the white roof. It's better to be reflecting that heat during the summertime and putting less load on your cooling system than absorbing that heat if the roof was black and putting more load on your cooling system during the summertime. And last but not least, there's insulation levels. And I threw that up there because every now and then we come across buildings where there's an attic where you can easily blow insulation in. But honestly, when it comes to the walls, or even if there's a roof where it's where there's really no easy place to put insulation in, it can be pretty costly to do that. And the only times I recommend installing insulation in the roof is if you're going to do a full-blown roof replacement. And at that time, they can usually, the contractor can install board insulation on the roof. But the walls are certainly a lot more trickier and costlier. Fourth component of energy use of buildings is plug loads. Plug loads, of course, is everything that's plugged in: computers, lights, refrigerators, coffee makers. I mean, the same building that we did in Avion here, where I took that picture of the infiltration. I mean, every person had their own coffee maker and refrigerator in their office. I mean, forget the central kitchen area. I mean, I shouldn't say every person, but God, there was like every office I went to, it's like there was refrigerators, coffee make. Everybody had their own personal kitchen. I mean, if that's the case where you work, the first step you could do is have a nice centralized kitchen and just get rid of them. Electric heaters, portable heaters are plug loads. And I realize buildings can be uncomfortable, and we'll get into that here in a minute. What could be contributing to why people need a portable heater. But, turning on the night setback modes, the sleep modes, all that stuff. Turning things off at the circuit breaker. It's funny, I was, not the circuit breaker, but the power strip. I actually, one of those things I've been preaching for 10 years, and I finally just started doing it about six months ago. I have a little, power strip underneath my desk, and turn it off and turn it on every day before I leave. That's how you know everything is completely off and your monitor's not in sleep mode and, consuming a couple watts here and there. This is an interesting concept, which presented to me, about 7-8 years ago on some audits we were doing for the Department of Energy. And one thing that they required for their audits was do a nighttime walkthrough. It's amazing how much you can learn about your building systems at night. And I recommend you do it unannounced. Don't tell the cleaning crew you're going to come in. But yeah, after the cleaning crew leaves, walk around and see what's on and what's off. Take an inventory of it. See who's leaving their computers on, who's turning them off at night. See what HVAC is running, what's not, lighting, etc. Make a note of it. Come up with an action plan. Figure out why this stuff is running. Let's see if we can try and turn this stuff off and keep it off at night. Something we came up against when we were doing this building tune-up program for down in Boulder, which is now being offered up here in Fort Collins, is equipment life expectancies. It's very difficult to go in and tune up a rooftop unit that's been on your roof for 30 years. Because the thing's going to potentially break at any point in time. And ideally, you like to tune something. It's like tuning up your 30-year-old car. I mean, you reach a point where you have to start doing major replacements. At that point, you keep on replacing transmissions and motors and engines, or do you just buy a new car? And so, these are typical life expectancies of the systems that you have in your buildings. And if you're way outside of this, you might be nearing having to replace some of those systems. And of course, new systems are more energy efficient, and they're easier to fix and tune and have more modern control features associated with them. In my experience here, recently gotten to work with a contractor the last 6 months down in Boulder, I find that they kind of just go in with their blinders on, replace the filters, and leave. John mentioned this in this presentation. Are they looking out for your energy efficiency? And that might be just of everything I've told you here in the last 20 minutes, ask them, are my systems running as energy efficient as possible? And, replacing filters is good. Are they checking the cleanliness of the coils? Are the condenser coils clean and the evaporator coils clean? The tension belts are good. Have they checked the refrigerant charge in a while? But the biggest of all those is the economizer setting. What's the minimum outside air your building's bringing in? Most buildings typically bring in about 10 to 20%. That's the minimum you want to be looking for. But is my economizer opening up when it's 65 degrees outside? Or am I having to run my compressor and run my air conditioner to cool the building? The idea is that when the conditions are right, when you're in that 50 to 70 degree range, you want to try and be using outside air to cool your building as much as possible, because that's going to reduce the energy use of the rooftop unit. Some other terms I threw up here that you may or may not have heard of. Commissioning, basically commissioning applies to new construction. Does anybody know if any of their buildings were commissioned when it was built? Okay, we got one person. Commission basically means going out and making sure the building works right from day one, as designed. We tested all the systems, we made sure they were calibrated. We made sure the building was working within the owner project requirements and the basis of design. And it's basically making sure things are comfortable. And usually commissioning directly correlates to energy efficiency. Usually non-commissioned buildings tend to use more energy within the first year than a commissioned building. And the reason for that is you get into this mode where the maintenance guy is just troubleshooting all these, some of these mistakes that were made during the construction process, where a commissioning agent will go through and kind of flush all those out. The last three terms are retro-commissioning, recommissioning, and continuous commissioning. Retro-commissioning applies to tuning up a building that has never been commissioned before. Recommissioning is commissioning a building that has been commissioned or retro-commissioning. And then ongoing commissioning would be kind of like what we just talked about with your maintenance contractor. Are you checking my systems quarterly or once a year to make sure they're running as efficient as possible? That would, on a smaller building, that would be an example of continuous commissioning. So I'm going to get into, in my next section, what we call the building tune-up program here in City of Fort Collins, and talk about how that can be used to help tune up your building. And basically, a building tune-up program is the same as retro-commissioning. But as far as summarizing what I just talked about, what does all this mean? What do you take back with you, back to your office, back to where you work? Well, the questions I would ask is, are you using premium T8s? When T8s first came out, they were 32-watt lamps. Now they come in 28 and 30 watt. So are we making use of the lowest wattage T8s out there? Are you using compact fluorescents instead of incandescents? Are you using T5s possibly? Lighting controls. Do you have lighting controls in your buildings? If it's just on-off switches, yes, that's a form of control, but it's not the most efficient form of control. We recommend occupancy sensors. For a room like this, an occupancy sensor might be a challenge, but when you got hard wall offices, conference rooms, break rooms, so forth, occupancy sensors are great for all that. You can even use occupancy sensors in bathrooms, but I recommend that you use a dual technology sensor that has ultrasonic as well as line of sight infrared. I threw recircuiting in there because, believe it or not, I want to go in and throw occupancy sensors or lighting controls on various lighting controls, but a lot of times the way the lighting system was circuited from day one affects your ability to control it. Like, for example, if you went into a lobby that was well daylit, lots of light pouring in, but the lights were on, and on that same circuit were the hall lights going down the hallway where it's not daylit, well, there's an example of the reason why those lights are probably on is because if I turn them off, I turn off the hall lights where it's dark. But if I recircuited that, I could put the lobby lights on a daylight sensor, and then the hall lights would be on its own circuit. And it's pretty common to see that type of situation out there. As far as HVAC system, are they 5 years old or are they 50 years old? If they're 50 years old, it's probably time to look into replacing them. If you replace them, you're looking at high efficiency systems. Just again, things get efficient as time goes on. VAV is good. Evaporative cooling is great. To give you kind of a comparison, where you look at like a SEER rating of a DX or a air conditioning unit might be somewhere around 12 to 15. Evaporative cooling is about 40 to 50. So we're looking 3 times more efficient. They're very efficient, and that's what we recommend using if you can install them. And then controls, making sure you have proper controls in your building. The envelope, all the things that we just talked about, weatherization, shading, insulation, cool roof. Have those all been done? Are those going to be done? Periodic preventative maintenance. When you go back and you see your maintenance contractor next, ask them, are you cleaning my coils? Are you checking the tensioning of my belts? Are the filters being changed out quarterly? And what else are you doing to help me save energy? Look at that scope of work. See what you're paying for. Ongoing commissioning. That's where we talked about calibration checks. If you have a much bigger building, are we making sure that outside air damper is still functioning, year in and year out? Those things do eventually break, or they freeze up, they rust. And of course, if you have a rusted damper that's rusted 100% open, that could be a big energy user. Our system's overridden. Control sequences programmed, optimized. And then last but not least, building schedules. Are your building schedules set to when you're there? Or are we running the HVAC system all weekend just because one person wants to come in and work in the building for 2 hours? And again, if that's the case, that's all right. We're not trying to freeze people out or make people wear t-shirts to work. But there's controls, there's ways around this stuff. There's overrides built into these thermostats, these programmable thermostats where you could, maybe not this one, but on some of them, where you could just push a button, override it for 2 hours, condition the building for a few hours and it'll automatically shut it off, instead of having to run the system. I hear that a lot where we have to run the system all weekend just for a couple people. And then this kind of ties it all back to the assessments that Fort Collins offers. How to get started. Here's some information here. And then what's included in those facility assessments. So, if this gets a little beyond your comfort zone, then you got these facility assessments to help you out. And that's where someone like myself or someone associated with the City of Fort Collins will come in and help you out. So consulting with a specialist. So consulting with a specialist. Now this is where, okay, we've gone from looking at your systems, what you have. Now we're actually going to diagnose them and figure out how we can determine whether they're working efficiently or not. And we get into, price recommendations, calculations, and then the outcomes. There's a couple of different ways to diagnose if your system is working. There's spot measurements, trending, actually testing the systems. There's tab, testing and air balancing. That's balancing the airflow coming out of your diffusers. Some of the tools that we use for spot measurements, there's a power meter, measuring the power use. Even though your motor might say it's a 10 horsepower motor, well, maybe it's only using 7 or 8 horsepower. And that's important information for me to have when I'm doing my energy calculations. Illuminance meters that measure foot candles. What we use those for is to see if the space is overlit, underlit. Of course, if it's overlit, it's using too much energy. And sometimes we'll do data logging on the building. Data logging can either be done through the building automation system or the DDC system, or we'll use portable data loggers. And the picture there is a pretty common type of logger called a hobo, where you can measure temperature. You got a temperature probe there, and you got a current transducer to measure power. And there's a variety of things you can measure there with a hobo. If we get into functional testing, what functional testing means is when I talked about doing calibration checks, checking if a temperature sensor is calibrated, or if a damper is working, or a valve is actuating correctly. Oftentimes, I need 2 people to do that. That's why I got a picture of the 2-way radios up there. I need one person sitting at the screen saying what it is, and the other person actually taking the measurement or doing the observation. So, we'll use a digital thermometer, maybe a CO2 meter if there's CO2 sensors, a magnehelic if we're checking, the pressure sensors to see if they're calibrated. Tab, also referred to as testing and air balance. Half the reason why your building may be uncomfortable is probably boils down to the airflow coming into the space. As the use of the space changes over time, so does the airflow needs. And so oftentimes we'll go in and measure the airflow and see how it compares to the original design and see if maybe the building needs to be rebalanced or a load calculation needs to be done. Well, if we collect I'm not going to go into the specifics of this, but I just kind of wanted to show you a visual that, this would be the output from one of those data loggers, where we trended a bunch of data, we're throwing it up on a graph, and we're looking at this data to determine how the building is operating and how it is controlled. And there's another trend here. So, your building is a lot like a car. Okay, the less it's maintained, the more energy it's going to use, and buildings are no different. So, aside from equipment being at the end of its useful life, a lot of time a building just needs a tune-up. Granted, if your building is, if your equipment's 20 or 30 years old, you probably need to replace it. But if it's less than that, oftentimes you can just tune it up. And those paybacks associated with tune-ups are oftentimes less than a year, sometimes even 2 years. So that's step 3. So now we're moving into getting a prescription. So this is kind of the focus of this section is the top 10 things you can do for these variety of scenarios, and basically these go from the easiest, quickest, best bang for your buck all the way down to more expensive options you can do in terms of taking your prescription and making your building operate more efficiently. So the first of those is conservation. We already talked about that. Turn things off. That's the best form of conservation. Culture is a big part of it. Getting people into the habit of doing things. Getting myself into the habit of turning off my power strip every night. Lighting retrofits. Again, the reason why lighting retrofits are so common is that lighting is a lot cheaper to retrofit. The paybacks are often 2 to 4 years. And as opposed to getting a crane out and dropping a new rooftop unit on the building. I mean, lighting is pretty quick, and that's why people tend to go after those next in line. Thermostats. This is another, probably even a little bit cheaper than lighting, but do you have programmable thermostats in your building? That's the, these things are now only $50, maybe even less. Pretty easy to install. I recommend installing a programmable thermostat and of course programming it. Don't just leave it in its default settings. And then also access is a big part of programmable thermostats. If it's in an office space in the middle of a cubicle farm, I recommend putting a lockbox around it and making sure only 2 people have the key, maybe you and the owner. The next one is the building tune-up programs, which I'm going to get into the specifics here a little bit on later, but that's retro commissioning a building, et cetera, optimizing the controls and the equipment to make it work more efficiently. And then there's, of course, HVAC systems. Now we're getting into more expensive, but yet, there's gains for energy efficiency off of them. High efficiency always makes sense. There's usually rebates associated with installing the next higher efficient piece of equipment. Of evaporative cooling, I think you should strongly consider. It usually does require a little bit more maintenance, but usually the energy savings outweigh the maintenance in maintaining an evaporative cooling system. And also, indoor air quality is tied directly to your HVAC system. And so maybe your current system has 100% recirculated air, but you want a new system that brings in outside air that could help your indoor air quality. Economizers are huge. Next beyond programmable thermostats and smaller buildings, the next big thing we look at is economizers, because that's really could be a big energy sink or a big energy saver. Of course, we want to make it an energy saver and make sure they're working correctly. The building envelope, of course, is important. I talked about some of the cheaper things you could do first, starting off with weatherization, maybe some reflective coatings on windows. But you start getting, a cool roof would probably be next in line. But once you start getting into installing insulation and things like that, you can certainly do it. I'm not recommending against it, but it's gonna cost more money to do that sort of thing. Appliances are important. It's getting to where it's hard not to buy an Energy Star appliance. That's just kind of the way the trend is going. But if you gotta buy a new microwave or a new coffee pot, make sure it's Energy Star. And then there's the green information technology, or IT, information technology. IT is a huge growing is a huge load growing on our infrastructure and our grid these days. All these data centers popping up, whether they're central data centers owned by a large company that sells off server space, or if they're internal. They're definitely a big energy sink. As we find ourselves becoming more energy efficient, we sometimes find ourselves becoming less efficient too. And data centers are kind of fall into that category. But the big thing that a couple things that jump to mind with data centers from what I've observed is the temperatures that are maintained in them. Oftentimes temperatures are maintained really low when you can maybe increase those 5 or 10 degrees. The lack of outside air economizers. There tends to be this fear that if we bring in outside air, it's going to destroy all the data center equipment. Well, compare that to an operating room that brings in 100% outside air. Bringing in dust and so forth is not a concern because they want 100% outside air in that operating room. And now we're talking electrical equipment. There's filters and technologies out there to filter that, those particulates out if that's the concern. But outside air, of course, is largely untapped for making data centers run more efficient. We see a lot of water side economizers, but not air side. People, culture, the cost of energy versus the cost of salaries. Always comes up, but everybody's always happier to see a lower electric bill, whether it's $20 cheaper or $20,000 cheaper. The goal is to keep people happy and productive, and none of what I'm saying here has to do with trying to make people more uncomfortable. We're just trying to make what you have work more efficient. And then we get into the water side, and that's something that the climate-wise assessments look at. There's indoor use, outdoor use. Leaks are always the number one water saver, besides just turning things off. Ways to save water, of course, are aerators on faucets, low-flow shower heads if you have showers in your buildings, low-flow toilets, urinals. A couple things I didn't see on this list that could save water too is, if you have a small building, a circulation pump. Even for a house, if you got one hot water heater for the building and you got to run the hot water for 5 minutes to get hot water, if you have a circulation pump, that can reduce water use. But then you can also argue it might increase your heating energy use too. But to combat that, you can also get like a point of use water heater. get like a little 2-gallon water heater that sits underneath the sink instead of running water all the way from the other side of the building. Both those can save water as well. Irrigation is a big deal. Of course, I'm sure we all have this experience that when summer shows up in Colorado, our water bill, goes up 4 times, and that's because of irrigation. And commercial buildings are no different. Watering and keeping that grass green and so forth. Of course, you save the most by turning it off. I'm sure we've all seen sprinklers running, maybe even on your own buildings when it's raining outside. Or after we just got a big downpour, we get those big downpours in the middle of the summer. So maybe installing there are systems out there that can actually detect the moisture of the ground and the recent rain amounts, and can keep the system off when the ground is moist. And other things that once through water use are other heating, cooling equipment blowdowns. Basically what we're getting into here is like cooling towers, boilers, things where you have makeup water associated with them. They can be, in bigger buildings, they can be big water users as well. And maybe even upgrading your dishwasher too. In step 4 here, what we're trying to do is get you to implement, right? You have your prescription, now it's time to take your medication, right? Back to energy efficiency, to get things implemented and get things going, we've done the site assessment, we've made the recommendations, we've determined what's wrong. Now it's time to get a meeting of all the decision makers together. Decision makers can be anybody on that list. And by the end of the meeting, the goal is to determine whether to move forward into implementation. If the answer is yes, which measures to implement. And let's move forward. Let's not just make it another report that sits on your desk for 6 months, 6 years, collects dust. Wow, that was a great report, a lot of great recommendations, but we haven't implemented a single thing yet. Let's implement, let's get things moving. And that's taking your prescription. So then implementing the treatment plan, step 5. The big barriers that we see here, of course, are money. Okay, so now I'm telling you to implement this stuff. Now you're coming back on me and saying, well, I have no money, Who's going to authorize this stuff? Well, authorization, that's why we get the decision maker in that meeting. Someone that can sign off, cut the check. There's always technical resources, availability and management support. All these sound familiar to you? And then last but not least, time. I can barely get myself to work in the morning, let alone do this stuff in my building. Resources, ways to overcome these barriers. Well, one thing we recommend is delegating. Having a champion within your organization that can kind of push these things through, make this part of their action items list. Maybe spend 10 minutes a day, 15 minutes a day, seeing where we're at. There's external resources. Fort Collins Utilities is a huge one. That's why we're here today. It's because of Fort Collins Utilities, and we're trying to be that technical assistance right now. And then they further help out with rebates, help pay for some of these improvements, help out with the money side. So when it comes to implementation, there's a couple different ways of doing implementation. Of course, there's self-implementing. You can just go do it yourself. The second one is, I have this contractor I like working with, we'll have him do it. Or the third is saying, I really don't know anyone. Who do you know? Can you bring someone in? And that's another way to do it. And oftentimes, if that's the case, you might need to keep a technical resource involved to make sure things are done correctly. If you do pursue going out and doing this on your own, we recommend getting at least 2 bids. And places to start, of course, is someone you like working with. If you don't have anybody you like working with, referrals from other businesses, your friends, people you work with, trade partners, that sort of thing. And then you want to apply for your rebates to get whatever money you can back from the utility. And that's the contact information for the rebates. And then, and that basically covers a lot of your capital improvements. But now if you're getting into, well, I just replaced my rooftop units 5 years ago, or my lighting is brand new, but I still feel like I'm using a lot of energy. Well, the other option to consider is the building tune-up programs. And the building tune-up program is synonymous with retro commissioning. There's 2 options here. There's for buildings over 50,000 square feet. There's a small building tune-up program for buildings under 50,000 square feet. And then a lot of this is offered in collaboration with Platte River Power Authority. So the building tune-up itself, the BTU program, this is buildings over 50,000 square feet. Basically, the incentive here is that Fort Collins Utilities and Platte River will pay for 100% of the cost to do the study. They won't pay for implementation, but they'll pay for the upfront planning survey to identify what, if you're a good candidate to save energy, and if there's lots of energy saving options in your building. They'll pay for the investigation implementation phases, and they'll pay for the verification. And really all you need to do is provide the manpower to help assist with the process and pay for the implementation yourself. And then also you have to have a couple other criteria here. You have to be committed to spending $4,000 or more. So there is that buy-in piece. You have to be willing to commit some money. You have to have no scheduled major renovations or capital investments, and you must be a utilities business customer. So all of those are required. And then of the minimum 2 requirements, you have to meet 2 of these requirements. You either have to be 50,000 square feet or bigger, you have to have a functioning control system, or you have to be a high energy user. Like say, for example, you're a 40,000 square foot data center. That might be a good example to get your foot in the door. So then the other program is the SBTU program, and that's basically for buildings under 5,000 or under 50,000 square feet. And there's a pilot going on right now this fall, but the full scale isn't going to roll out until next year, 2011. And this provides both an evaluation and a tune-up of your building with a budget amount up to $5,000. And now the difference between this and the building tune-up program, besides building sizes and costs and all that stuff, is that this is what we call more of a wrench and fix model. You know, we're going to spend less time putting together reports, collecting trend data, crunching numbers. We're just going to go out and figure out what's wrong with your building and fix it. And then we'll come back and we have prescriptive savings numbers that we will have put together for typical buildings and typical sizes of equipment to come back and estimate the energy savings on the backside. So, you know, what's nice about this program is we're just going to go out, instead of writing a report and explaining how I'm going to fix all this stuff, I'm just going to fix it when I see there's something wrong with it in the field. And that's it.
I hope this analogy has been working for people on the medical side. So you've kind of, gotten your vitals checked. You got the general physical exam or checkup, which is our assessment process. And then depending on what we learn there, you go in to consult a specialist and get some more diagnostic testing done and figure out exactly what's wrong so that we can get that prescription piece done. Now you're finished with your work and you can forget about it for the rest of your life. Actually, no. What we'd like to do is wrap that into the ongoing piece. And I know that a lot of these blend together as we've been talking about them this morning. So the idea of continuous commissioning is essentially a wellness plan, et cetera. But it's not the end, but just part of hopefully a cycle that brings you back basically to the beginning again. So we loop around to checking our vital signs and how we're doing. There is a piece of, if you've done some project work and gotten some rebates maybe from our program, well, we have a responsibility to go check and actually the work that got done was done well and we got the savings that we expected on it. So there's a verification step piece to that. And then you already have the tools in place, the bill analysis and benchmarking pieces that you put together. Those are done and ready to go. So you keep using those and hopefully start to see those benefits that we expected up front. And similarly with your employees and your service providers. They were the ones you started with on identifying whether things are working well, not working well, what are those symptoms that we're trying to address. And we've kind of presented this as if you do it all at once. The reality is not all at once. Usually it's like, well, we can do this year. You know, we may have to do something else, wait until the next budget cycle. So it's not really the nice clean picture of start here and end. It's more of different pieces are going in these cycles, and that's where an integrated approach really makes sense. The verification step that we do, it really depends on the project. A lot of our programs have some specified savings up front. Larger custom projects will come out and be crawling around looking in your building and making sure things are working as we intended. You still have those tools in place on the benchmarking side, so make use of them. keep tracking those bills as they come in dollar amounts as well as in absolute energy terms, and understand how you're doing. Again, is there work still to be done? There probably is. We never get everything in that first cycle. I do want to spend some more time on this integrated approach. We talk a lot about saving energy, saving water, reducing our waste, etc. But the goal here is to solve multiple issues simultaneously. So if you take an integrated approach and get the right people from your maintenance staff, the owners, your service providers, designers, etc., you want to save money and add value to your building, add value to your business. You should be able to, when you look at lighting HVAC projects, you should be able to both save energy and improve the indoor environmental quality of your building. We don't just do lighting retrofits because they save energy. That's the time to look at the design requirements, look at what your building should have for lighting, what it should have. Similarly with across all of these pieces. So take that integrated approach, ask all the right questions, take the time to design that in up front, and we'll get the best outcomes. It really is about indoor environmental quality. It's one of my soapboxes is that we all have been in spaces. You walk into a building and you're like, this is nice. I'd like being in this. That's because of the way it was designed, the way it operates, and it meets those air quality, lighting, thermal, acoustic, and aesthetic qualities that make it nice. That brings people to your business, keeps your employees happy and productive. It's going to make, all in all, much more successful than the alternatives, which we've all probably worked in some pretty miserable buildings as well, or certainly been in them. We've talked a lot about our programs. I guess our goal, and part of these, one of our goals in these environmental program series is to get you to call us. It's as simple as that. So the steps that we've talked about are all part of our processes for our rebates and technical assistance. We also have programs that Jim described on building tune-up. We have one for new construction. If you're going to be building a building, our integrated design assistance program is designed to provide this type of assistance for a new construction process. The ClimateWise program takes all of this, adds a few other pieces, really the solid waste recycling, and also looks at transportation efficiency for your business, your employees, how people are getting to and from work if you have fleets, and looks at that, and also provides a network of businesses that are learning from each other and recognition for your business in terms of your accomplishments towards towards reductions in carbon emissions is kind of the metric that the ClimateWise program provides. So many of these things overlap, but ClimateWise takes it further and really gives you that recognition piece in the community and with your customers. We have, I think, plenty of time for questions. The question was about the metric of KBTU per square foot and what a good examples might be. Remember, an example is only valid for a particular type of building. So schools we come back to that both because of Poudre School District's efforts as well as schools are pretty typical. An elementary school in Fort Collins is pretty much like an elementary school in Thornton or in Colorado Springs because they're all about the same size and number of students. And so there's a great set of numbers. But the Poudre School District's latest school, I think, is in the mid-20s, 25, say KBTU per square foot. An average school is probably 60 or 70. So they are, at a third of what it might be. We were, for the new Discovery Museum project that's being designed right now, I'm going to go over in near Lee Martinez Park. We asked for a number up front. We said we want the design team to shoot for 40. It has some displays, museum lighting, things like that might push it up a little higher on a typical scale. Their current design is in the low 20s. So they have exceeded even our goal by almost 50%. I don't know if anybody else in the audience remembers what, like one of our office buildings. I know a couple of our buildings in the city are we're working on them. Some of the older buildings have some pretty low scores that may be in the 80 range for an office building, but really depends on the type. So the question was related to the kind of what we call the split incentive between owners and tenants, in the case that the owner typically has is responsible for the capital upgrades that might be required for some of the things that we're talking about. The benefits accrue and the utility bills are paid for by the tenant. It is a difficult, I mean, that is one that we spend a lot of time talking about. A best bet is really in getting everybody, the right people in the room to be able to have a detailed and rational discussion about it. I mean, in some cases, the value of the space, the value of the building can be a good argument for owners in their sort of competitive market, depending on how competitive the leasing market is. That's one avenue. Oftentimes, depending on the age of those systems that Jim was talking about, they may need to be upgraded anyway. So that's the time to make those decisions. And lastly, there are, in some cases, some of the upgrades have a short enough payback. Some of the lighting things we've seen can be in the order of a year to 2 years. So depending on the sort of the how many years, whether that space works for you and you think you might be there in that time frame, it might make sense to end up maybe sharing or splitting that cost or working with. So we've tried to sort of broker some of those sometimes, but there's no easy sort of silver bullet for that one. Is Adam here? He would know that number off the top of his head. I encourage you to come to one of the sessions this afternoon. Adam Perry might be able to give a better answer, but they're probably in the maybe 3-4 year range. So what's being talked about now is for the last few years, we've primarily been upgrading the older T12 lamps, the 1.5-inch diameter lamps with magnetic ballast, to a current technology T8 lamp and electronic ballast. Well, even within the T8, you can actually jump an entire generation of T8 lamps and go to high efficiency ballasts with high efficiency lamps, higher color rendering and lumen output lamps, and essentially skip a whole step in there. So we are starting to see some projects where we are retrofitting standard T8 equipment to a high efficiency T8 equipment and seeing a pretty good payback on that. And then that's certainly much more common on either coast as well. So they retrofitted the T8s 15 years ago. They're retrofitting now to high efficiency T8 equipment. So if you still have T12s, don't put in standard T8s. Make the leap and get even more savings.
I want to talk, well, first of all, if you're not familiar with exactly what LSI Corporation really is, I will give you this note from the corporate website. And basically what it says is that LSI is a high-tech corporation that provides products for most of the networking and storage equipment that you'll find across the U.S. and around the world. So what I want to talk with you about today, I want to talk about three things. One, I want to talk about LSI's commitment to reduce our contribution to greenhouse gases, and you'll understand why that's important in terms of energy reduction as we go forward. I also want to talk to you about what LSI has done right here in Fort Collins to reduce our energy consumption and greenhouse gases. And then I want to talk a little bit, just really briefly, about what LSI has done across the U.S. In reducing greenhouse gases. And I kind of want to use the term greenhouse gases and energy kind of interrelated here, because it's clear that the two have this relationship, that if we reduce energy consumption, we're going to reduce greenhouse gas emissions as well. So first, let's talk about LSI Corporation's commitment to reduce greenhouse gas emissions. This is significant in the way it impacted the rest of the discussion we're going to have here this morning. In 2007, our corporation signed an agreement with the EPA to become a partner in the EPA Climate Leaders program. And in that agreement, we agreed to reduce our greenhouse gas emissions by 15% from the 2007 baseline by the year 2012. I think those of us who heard about that agreement and learned about the content, I think we felt like that was going to be a significant challenge to accomplish. And as it turns out, it has been. The first thing that we did as LSI Corporation, we formed a USA-wide energy team That energy team is made up of individuals from environmental health and safety and from workplace solutions, and you may know that as facilities. The H&S representatives would be responsible for the reporting requirements that we have to the EPA, and the workplace solutions part of the team would be responsible for identifying and carrying out those projects, excuse me, which would reduce greenhouse gas emissions. The significance of our signing that agreement was that it raised the awareness within the LSI senior management team about the value of reducing energy. And said another way, it gave us that, the avenue to get funding for energy reduction projects. Next, let's talk about what LSI has actually done right here in Fort Collins. The first thing we did was to join ClimateWise. And as you probably know, Fort Collins ClimateWise is an innovative program that I haven't found in other communities where LSI has sites. It is very supportive of any industry effort to reduce energy consumption, solid waste, water consumption, all those sorts of things. The immediate benefits that we saw from joining ClimateWise, one was to get support from a consulting engineering company called the Brendel Group, who helped us identify systems and solutions for improving our energy use. And second, we learned about the incentives that were available from the utility, from Platte River Power Authority. And again, Platte River Power Authority's incentive program is unique, I think, in the communities where I have other sites. So starting in 2008, here are the steps that we took in Fort Collins. We identified 3 projects and got funding for all 3 of them. And you've heard about a lot of these already from discussions this morning. One was to replace the old inefficient magnetic ballast T12 light fixtures in our building. We had about 800 of those fixtures, and we replaced those with modern electronic ballast T8 fixtures. And I have to admit, they are 32-watt T8 fixtures, so we've had a discussion about maybe even a way to improve that efficiency this morning. But the cost of that project was about $130,000. We received a very large incentive of about $52,000, reducing that net spend quite a lot. The second thing we did, our building was built 1979 through 1981, so it had a full pneumatic control system for the building system. Over the years, that system became very inefficient and really didn't work very well. And in fact, in some cases, the pneumatic controllers could no longer move the outside air dampers very well. So we lost control of that and lost the benefit of free cooling. So we replaced the pneumatic control system with a digital building automation system, and we replaced the outside air dampers as well. In addition to that, we placed variable frequency drives, VFDs, on all the fans, supply and return air fans. And that allowed us to be able to manage the airflow based on actual demand rather than just running the fans full all the time. And the third project was that we installed variable frequency drives on 2 of our 3 300-ton building chillers. That again allowed us to match the chiller with demand. And so for those 3 projects, we spent a total of $455,000, which was a lot of money to ask for from our corporation. But because of our commitment to reducing greenhouse gases, we were able to get those funds. And of course, we did receive a very nice incentive of about $123,000 for all 3 of those projects, so the net spend was $332,000. All those projects were completed in 2008. So you may ask, how did it turn out? What were the results? So the way it turned out was, beginning in January of 2009, I began to compare the month-to-month energy bills for natural gas and for electricity, and we were able to realize a savings in 2009 of about $208,000 from the previous year. Now you could say, well, maybe there's some weather changes or maybe there's some other things that may have had an impact, and you're right, but the fact is $200,000 is still $200,000. The interesting thing about this is that $200,000 savings isn't just for 1 year. It's for every year you operate. Sometimes people tend to lose that sight of that fact. So the project paid back in just about 2 years. That made it, when we were able to show that, it made it even easier to get future funding for projects from management because we really did deliver on the promise that we were going to save energy. I also note here that the calculated greenhouse gas savings calculated as CO2 was a bit more than 2,000 metric tons of CO2. And we didn't stop there, of course. We identified other projects. I think what happened was we got into the mindset of trying to figure out what kinds of innovative things can we do. I mean, we've had success already with some things that were easily identified, sort of the low-hanging fruit kinds of things. But now there must be other things we can do. And in fact, in 2009, we realized that we had a storage building on our site that we were conditioning. We were keeping that building from ever getting below freezing. And we asked the question, why are we doing that? What's in that building that actually needs to be protected? It turned out the answer was nothing. It's like pipe and wire. Do we need to keep that from freezing? I don't think so. So we were able to shut down the hot water supply that was being pumped from the main building underground out to that building and back. So all the pumping energy and hot water that was running out there, we were able to shut that all down. Now we had one little hiccup in this, and that is that the building had a partially water-filled fire protection system. And we knew if we let the building freeze, that was going to freeze too. So we partnered with Poudre Fire Authority, PFA, and they agreed that we could indeed mothball that system and drain it so it was no longer a problem. We also installed a variable frequency drive on our third building chiller because we realized that we needed to be able to ramp down all three of them. Our demand for cooling had dropped to the point where we needed to be able to run at some times less than one chiller, which we'd never been able to do before. In 2010, we replaced some oversized air compressors. We had some very large air compressors that were an artifact of when we used to have a large manufacturing operation in the building. They were really oversized for current demand. So we found some right-sized compressors, bought those and installed them. Now we didn't get an incentive from the utility for doing that because it was a replacement. But we still believe that with the energy savings that will pay back in about 5 years. And what are we doing in the future? Well, we worked with a lighting designer, professional lighting designer, to take a look at all the exterior lighting on the building, parking lot lights, any kind of door lighting, anything that was outside. And we have a plan to replace all of our parking lot lighting with LEDs or in some cases CFLs. But unfortunately, we reached the point now where the payback on this project is about 20 years. So we're unlikely to get funding from the corporation in one big lump to do this kind of a project. So we'll probably kind of work at it piece bit by piece bit as replacements when something fails. So you may ask the question, what were the results? And so here's a set of charts that shows the energy demand for natural gas and for electricity. You can see how they've trended downward. I will give you the caveat that the 2010 bar is only for 9 months of the year, so it didn't really drop off that much. It'll go higher. But you can see that the requirement for natural gas definitely trended downward, and in fact we probably realized a larger reduction in natural gas than we did in electricity. So now let's talk about what LSI Corporation has done all across the USA. I don't want to talk about this in great detail, but just to kind of give you an idea, since we started talking about LSI's commitment to reduce greenhouse gas emissions, let's talk about what we've done across the USA. The corporation also funded projects in California, in Kansas, and in Pennsylvania, the large sites that we have across the country. And we funded in Pennsylvania some building automation system upgrades and also some retrofits to improve the use of free cooling. And in Kansas this year, we're currently installing a digital building automation system in an old building, very similar vintage to the one here in Fort Collins. And in California, we took advantage of demand response programs, that is, letting the utility tell you when peak demand moments were, and you could maybe shed some load to try to reduce that demand charge. And also hot aisle, cold aisle containment in data centers. And if you're not familiar with that, it's basically a way of isolating in a data center the place where you need very cold air, which is the front of the server, and letting the hot air blow out the back of the server and getting that out of the room. And that's been a very successful program. In fact, we've also done that in the Boulder, Colorado office, and it's been very successful there too. So you can ask the question, how has LSI done so far in regard to our commitment to reduce our greenhouse gases by 15% by 2012? So by the end of 2009, LSI had reduced its contribution to greenhouse gases by about 8.25%. Preliminary results for 2010 indicate that we may reach 11%. So you can see that reaching the 15% goal remains a significant challenge. And as you've heard here before, one of the reasons is the increasing size of server farms. Our company is very involved in storage, and we have a large demand for increasing the number of servers that we have in our buildings. And that's always a threat, both in just powering the servers and then having to cool the heat that they generate. And today, unfortunately, projects are beginning to have a longer ROI. And when that ROI gets longer, it's more difficult to get the corporation to fund those projects. So here's the graph that shows kind of how we've done. In fact, on the left you can see the 2007 bar, and the red bar on the right is the 2012 goal. And again, 2010 is not a full year. So you can see that we're headed toward the goal in the right direction, but we're not there yet. And that's all I have. Anybody have any questions? Yeah, fair question. And if I understand, oh, I'm sorry. So the question was, how do we calculate greenhouse gas emissions by reduction of energy? And the answer is, we get essentially from the utility, we get a number, an equivalent number that says, for so much energy, you will contribute this much CO2. And we got that from our natural gas supplier, and of course for the electrical side from Fort Collins Utilities. And then that would be true in any community where we have where we've done this. If it was in Pennsylvania or whatever, you would get from that local utility that sort of a correlation. That's how we would do that. So the question was, have we done anything with behavior modification in terms of our employees to try to help reduce electrical load? The answer is yes. I would say not necessarily successfully. What happens in a high-tech company, a lot of the load is that sort of desktop unit that it's a PC or it's some kind of a workstation that the employee will use at his or her job, right? And in some cases, they don't want to turn those off. Because the startup time in the next morning is very long, or they're concerned they'll lose data if they shut it off, that sort of thing. So that's difficult. I think you kind of have to weigh that concern with what the business issues are. And I think we've taken some other major steps to really try to reduce energy consumption. I think we've been successful. We have more work to do, but I'm not sure we're going to make great inroads that way. The one thing I did forget to mention that I'll go back and touch on was we talked about the lighting retrofit. And that is that when we had the old T812 system, we had like 3,800 degree Kelvin lamps, which would be pretty typical. And when we retrofitted the T8 fixtures, we put in 5,000 degree Kelvin lamps. And we heard talk about color rendering index and stuff this morning, right? So if you actually took a light meter and put a light meter at the desktop, it turned out that the number of lumens was actually lower at the desktop with the T8 fixtures. But the perception on the part of the employees was, it's much brighter in here. It was because of the color temperature was 5,000 degrees instead of 3,800. And in fact, since we replaced all the fixtures all at the same time, it meant all the lamps were new, so it was really bright. And as over the course of time, those lamps, of course, have dimmed a little bit, and it's gotten a little bit maybe less bright. Yeah, that's a fair question. So the question is, what was in the implementation process, what was easier, what was hard, or surprising maybe? I think what really, I think the most surprising thing for me was that once we installed the digital building automation system, we just didn't sort of set it and forget it. We kept working at it. I happen to have a really terrific guy in my organization who's very knowledgeable and very interested in kind of fine-tuning that system. And as time has gone on, he has found ways just to keep tweaking it, where we keep reducing energy all the time. And he's always working on finding new ways, very creative ways to make that work. In terms of implementation, probably I don't remember any real surprises in terms of implementation. That I was. I was surprised how much we got back for incentives. That really, actually, he's joking, but the fact is that was hugely important in those initial 3 projects. When you generate the ROI for the company and you can show them that we're going to get a check from the utility if we do this, and we got those checks, that really helped sell future projects. So we can joke about it, but the fact is it was a huge, huge part of that effort. Thanks. Thank you.
It's kind of good to look back at all the things we've been able to accomplish over the last 10 years. I've been the United Way facility manager for about 15 years, but you have to keep in mind that very few of us have one single job. There's multiple tasks and other duties as assigned. So during that time, I've been learning to become a facility manager. United Way of Larimer County leads the community to meet the needs of those in need. We're a nonprofit organization. And our goal with our facilities is to provide a public building that's pleasing, friendly, and accessible. We're also interested in keeping the costs low, and we have many resources that help us with that. For every $1 that I save in operating the facility, it goes back into programs. This is the building at 424 Pine Street, which is built on city property. It was an amazing community collaboration project back in 1985 was when the building was built. And that involved many of the local municipalities and Larimer County to come up with the money to build this to provide a stable place for nonprofits to work from. The other thing that's unique about our location, which is on the Cache Laputa River, about a block east of Northside Atzlan Community Center, this was also the site of the original Camp Collins, or I should say the redone Camp Collins, because the first one got flooded out in LaPorte. So here we are on this very historic site. We have a 20,000 square foot building, and 8,000 of that is the Teaching Tree Early Childhood Learning Center, and my number does not add up to 20,000. We actually have 12,000 square feet of office building, and 16,000 square feet is the actual suite sizes, not including all of the common area. So this is an interesting combination of office building and childhood learning center. We have the Learning Center open from 6:30 in the morning until 6 p.m. We have to meet licensing requirements by the county health department, state child care licensing, etc. So we have a lot of scrutiny on all of that. One of the things that I saw right away was that our utility costs were a very high line item in our budget. And starting from about 2001, I'm happy to say, well, I should say that I just learned not too long ago when we were having the facility assessment done, there's actually been a downward trend. And that's been the goal, and it's good to see on paper. We have started out with many different projects, and I'm going to give you kind of an overview of those. In the facilities assessment, I just copied and pasted this. They gave us existing practices that are the good things. We have used solar shades, implemented efficient lighting, programmable thermostats with setbacks, added clothes dryers powered by gas rather than electricity. We've replaced carpet with high recycled content, and we use recycled furniture. Whenever anybody needs to close down an office, they call up United Way and say, can you use something? And we usually can. Over the years, here are the things that I've done. starting back in approximately 1999, we changed out the LED exit lights. And I also changed out the switching in the hallway. There was one switch that kept the lobby lights on and the hallway lights on all the time, and that didn't make any sense. Today, my boss usually arrives at work before I do, so he turns on the lights in the hallway, and then I come in behind him and shut them off on most sunny days. We have a beautiful building that was designed by George Brelick with RB+B, and there's a lot of natural daylighting. Not only are there 44 windows facing south along an east-west hallway corridor, but there are interior windows that bring natural daylight into much of the office area. I kept hearing about lighting retrofits, and I thought, well, changing out light fixtures, we just don't have the money. That's really disruptive. And then finally the light bulb went on. Well, no pun intended. But it was, oh, you mean you just changed the ballasts and the lamps? Okay. What a significant project that was. It gave us not only a chance to reduce that cost by 30%, or I should say our usage by 30%, but I also went through and made some changes in a few light fixtures just to improve it. It turned out that it was as easy as it could be because the contractor had it figured all out that he could get my paperwork done for me, he could help me implement it, and then the check for the rebate from Platte River Power Authority and the city showed up almost as my invoice showed up. And that rebate paid for the labor costs of doing all of this work. So that was a really easy one to do. A benefit along that line was the contractor was doing a lighting project in a motel, and I had said something about wanting to have more options for lighting in the offices because some people, no matter what, just hate fluorescence. And he happened to provide me with some of their old wall-hung lights, which I had a volunteer paint, and we take them down, put them back up as people's choices change. We have had a significant heating and air conditioning problem. The file was pretty thick on the problems from the day it was open. You know, this 1985 was before commissioning was done, so what we did was a retro commissioning before we even knew that's what it was called. Just to give you a picture, we had all that south-facing glazing, and we had a suite that was heating and cooling on the same zone as the offices on the north side of the building, facing west and north, and second floor and first floor. So there was an absolute problem there, and I don't even have to be an engineer to do that. After talking to lots and lots of people and hearing lots of presentations, we actually called in an engineer who specializes in retrofitting, and she went through and discovered some things that I think just a hardware salesman would not have looked for nor found. So we did a lot to improve the system. I'm going to talk about the sunscreens that we did during all of that, but I would tell you that as I did the lighting retrofit first, and the engineer redid her calculations on our cooling load as a result of that, because we were looking ahead to needing to replace the rooftop units, and it really had a significant impact on the cooling load. We've put in new controls for the HVAC system, and one of the important things that we did was to remove the part of the building that has all of that greenhouse glass to their own split system. So now they're on their own, and it's all working much better. We did some additional steps, like in the tall part of the building there are steel framed windows, and for settling or whatever reason the seals had broken on those windows and they needed to be replaced. The rest of the windows in the aluminum frames were doing just fine. I went to I did call up the architect and ask for help in selecting the glass He's been really helpful to me that way, and it met the guidelines of the City of Fort Collins and Platte River Power Authority. So again, we were able to get a rebate, not a huge rebate, but, or I should say incentive, but it was enough to help, and it was finally time to get the work done anyway. We have, last year, we've enlarged the child care center program to include infants, and we had to add more laundry equipment, and that was a good time to convert from using electrical dryers to using gas-powered dryers. And at the same time, we actually took out the old, now what would it have been, 25-year-old mechanical time clock that was really awkward to get reprogrammed with the changing seasons, and put in a photocell. The electricity is still our highest utility cost and the one that I look to change. We're paying a lot of money for the peak time usage. We're going to be working on our control system to change this coincident peak demand problem. So we have more steps to take. It now exceeds what we're using. There's something bad with that picture. We're replacing our incandescent fixtures on the exterior of the building, taking it from the 80s to a new look, 2010, LED exterior lights. Actually, I'll be rushing out today, that's going to happen. We're going to be upgrading the programmable controls for HVAC equipment in the child care center. And one of the most important things that we've done this year, and I guess I didn't realize how important it would be, is that we finally became ClimateWise partners, and it was both United Way and Teachy Tree that became partners. And what that meant was, when I announced that to our organization, to our staff, that sort of changed everybody's attitude about who's responsible for things. And whereas a person that I had been talking to quite a bit for quite a while about, couldn't we just get rid of those big containers of water in the dispensers? We have Fort Collins water after all. What's the point of bringing in Fort Lupton water, running it up and down the highway, just so you can take it out of a bottle? It's not good for anybody. And it was really falling on deaf ears. And then I stepped back, and then this person that I'd been talking to said, and guess what? This is really going to reduce the carbon footprint of this facility. And so it has been interesting to watch what happens. Of course, we've throughout all of this done our recycling programs, and that of course has changed as services became available. But now people are saying, could we maybe have that meeting and not print out a copy of an agenda for everybody when we only have 3 items? Can we kind of do without that? And that has been a really wonderful thing to see. And it will, at the end of our year as a ClimateWise partner, I'm looking forward to doing this calculation work of what have we really accomplished. Now, one of the things that I wanted to show you is the, oh, could you bring that up? The screen project. One of my greatest resources is the use of volunteers. If anybody gets a DUI and needs community service work, I can use you. Oh boy, can I use you, depending on your skills. At a certain point, our controls were hosed, and we hadn't split off the greenhouse down there. But what I did do is, I remembered back from the 80s when we were building sunrooms and greenhouses. There was a product, and in fact one of the people in our building had built a greenhouse on her home during that period of time and said, well, here's some stuff, Jean, and it's called fiberglass sunscreen. Sunscreen is actually the brand name, and I remembered it. And she'd had it on her greenhouse for 25 years. And I used the services of a community service volunteer to build screens. That's all it is. However, it blocks 90% of ultraviolet. And I was so excited the first day that he put in the very first screen. I took my little thermometer on the inside to measure one window with the screen, one window without the screen. And it was in the winter when there was, you know, the angle of the sun was down, there was a lot of solar gain happening, and it was 10 degrees difference. What that has done for their office, not only did it help us through that awkward period where we didn't have good controls and didn't have the system split out, but it actually reduced glare, because all this glass is not low-E glass. It reduced the glare and it gave them privacy. They can see out just fine, but people can't see in quite so much, and it's really improved operations. I had another volunteer come to me who was, I knew very capable because he is a machinist, and I did all the rest of the windows. And what I can tell you is I spent about $1,200 worth of materials, and I ordered them online from a distributor in large rolls and big cartons of aluminum frame material. And I know that it was going to be triple the cost anyway to go have them commercially made, but it has contributed greatly to our reducing our cooling load during the summer. And in fact, I talked to the city utilities about the project, and because it was so economical for me, it didn't even meet their minimums. So there. I've used resources over the last 10 years to identify help and really good, solid information. The City of Fort Collins, I've gone to all those meetings, Platte River Power Authority, and many of those meetings I attended were with the Rocky Mountain chapter of IFMA, which is the International Facility Management Association. If any of you are interested in learning more about that, I'd be happy to tell you that we have monthly meetings with lots of programs that are timely topics, including energy conservation. I've attended all those information programs. I've used specialist staff help from the municipalities, actually hiring a consultant. I had someone from Neenan Construction come over and gave me an HVAC 101 course, one-on-one, to help me understand what I should be working towards. And I feel that whenever we were able to qualify for the incentives, it gave validity to the project. It meant that we were meeting at least some minimum requirement that was going to be good for us in the long run. And because we're operating a community building, we really are stewards for the future. And whenever we invest in something, we want it to have a long-lasting impact on the serviceability and the function, and of course playing a good citizen role in our community. So that's my story, and unfortunately I haven't gotten all of the things checked off my list yet, which is why I haven't retired yet, but I'm getting closer. Thank you.